Okay. So, hi everyone. This is Srikanth Yadav, working as Assistant Professor, Department of IT, VFST at Dmt U4 University. So, in this data mining techniques digital content series, we are discussing about classification techniques. In previous sessions, we discussed about data pre-processing approaches, introduction to data mining, and various association techniques. Now, in this session, we'll focus on the concepts of classification. That means what are the concepts are going to be covered in this classification and what are the various techniques. We will see with suitable examples. So in this aspect of this digital content, the learning objectives and learning outcomes are, here we are going to study about the basic classification techniques. That means how a classification is going to be implemented and how the data modeling is going to be completed and what are the various classification techniques which are available. And we'll see the commonly used approaches like decision tree approach, navy Bayes approach, neural network approach, and k-nearest neighbor algorithms. And upon completion of the syllabus, the students are able to understand the basic classification techniques and approaches, and they are able to apply data classification techniques in real-time applications. If you look at the syllabus, here where the total syllabus has been divided into various groups based on the type of classification approach, like statistical approach, distance-based approach, decision tree-based algorithm, neural network-based approach, and rule-based algorithm. And finally, we'll see the combination of all the techniques. That means the usage, the type of the data, and the classification. Using all those aspects, the syllabus has been framed. If you look at the agenda, here we are going to discuss about techniques like what are the basic concepts or introductory concepts of classification. We will discuss in the basic algorithmic part. And when it comes to the statistical based algorithms, here we will focus mostly on regression technique and Bayesian algorithm. How regression is going to be used in classification and prediction, and how Bayesian algorithm or naive Bayesian algorithm are going to be used in classification. When it comes to the distance-based algorithm, that is based on the similarity, we can apply algorithms like decision tree, simple, k-nearest neighbor algorithms will apply. When it comes to the architectural related and data storage aspects, tree-based algorithms will use ID3, C4.5, C5.0, CART algorithms. And we will see some of the concepts of scalable concepts of decision tree algorithm. And another aspect of data deriving using classification is neural network based algorithms. We will see the propagation, that is data propagation, supervised learning approach, radial basis function approach, and we will see the basic concepts of perceptron. And we will see various rule-based algorithms. That means to classify any data, to derive any data, what are the various rule-based approaches are there? We will see those approaches. And finally, we will see the various combination of techniques and combining techniques in classification. Now, what is main goal of this syllabus? Here, the main objective is we want to provide an overview of the classification problem and introduce some of the basic algorithms. That means upon completion of the syllabus, we can be able to know what are the basic concepts of classification and how can we apply various classification algorithms in real-time applications. So these are the techniques we are going to discuss about. They are regression, distance-based, decision tree, neural network-based, and rule-based. Let's see the introduction of the classification. Now, before seeing the technical definition of a classification, we'll see one small real-time example so that we can understand what is a classification. Let us assume we want to see whether the student is passed or failed. That is, we want to predict. Let us assume here we are having marks like subject 1, we are having subject 1, subject 2 and results, that is pass or fail. Like in this subject 1, assume the student has got some 35 marks. In subject 2, he got 50. And based on the cumulative of these two, we want to predict. Like he is passed in both the subjects. Let us say it is a pass. One student has got 20 marks in subject 1. He got 36 marks in subject 2. So he passed in one subject, he failed in one. We will say fail. Let us assume here he got only 30 marks here, and here he got 2 marks, 20 marks. Now I don't know what is the answer here. Now here he is having some 50 marks, 60 marks. Here I don't know the answer. Look at carefully. In first row, the student 1 has got 35 marks in subject 1. He got 50 marks in subject 2. We are saying passed. On what basis? We know. Because less than 35 marks, we can say we are considering it is a fail. More than 35 marks or 35, we are calling it as a pass. So based on here, we applied some basic mathematical rule. If marks are greater than 35 or greater than or equal to 35, we can say pass. Less than 35, we can say fail. Here he got failed in one subject. So obviously we'll say. Now using the knowledge of these two rows, we want to answer these two questions. The student has the 30 here, one subject, and he got 20 marks in another subject. Now what is the status of the student? Whether he is passed or failed. Based on the above knowledge, we can say he is failed because he didn't get not even a pass mark in single subject. If you look at the second unlabeled data, here values are there, but there is no label here. Now by using the previous knowledge, we can say he is passed. Now if you look at carefully, knowingly, unknowingly, we are taking some knowledge from the existing data and we are applying that knowledge on the data. This is called classification. Here, in the last column, we are applying some values. Like to indicate whether the student is passed, we are using P. To indicate if he failed, we are using F. That is, P and F are the class labels we are using. And the class labels, whatever we are using, in first two rows, they are already given. But in third and fourth row, they have not given any value. The only thing is we want to identify. So this is called the classification. Okay. Now it is the most familiar and most popular data mining technique. When the class label is unknown, or whenever we want to give a class label to unknown data, we can use classification approach. The commonly used real-time applications are image and pattern recognition, medical diagnosis, loan approval in banking sector, detecting faults in industry applications, and classifying financial market trends. In all aspects, we are applying classification techniques. Now, what is a technical definition of a classification and what we are doing in this classification? Let us assume we are having a database, capital D, with some transactions like T1, T2 and so on up to T, and a set of classes C1, C2 and so on up to Cm. That means these are the values and the C indicates the labels, or you can say class labels. Now the classification problem is to define a mapping between data and class labels, that is DNC. Data and class labels. In previous example, data is student marks, C is class label, pass or fail. So here what we are doing, we are creating a mapping between D and C. Now what it will do here, actually we are dividing D into equivalent classes. We are dividing D into equivalent classes, and what we are doing, we are trying to predict something for unknown value. Predicting is similar but may be viewed as a having infinite number of classes. So here when we are having a data the data has to be mapped with any one of the class label. If you are having marks of the student, the class label can be pass or fail. If you are having customer data, the class label can be based on the customer behavior pattern. Good customer, very good customer, we can say average customer. Now, we'll see one small example here. These are the some of the real-time examples. Like we want to divide the class students based on their grades. Based on obtaining the marks, we can divide. Like if any students get greater than or equal to 90 marks, we can say A grade. 80 to 90, we can say between 80 to 90, we can say B grade. 70 to 80, we can say C grade. 60 to 70, we can say D grade. Less than 60, we can say F grade. That depends. That means we are applying classification to assign grades of a student. And if let us assume to identify the status of the mushroom, whether it is poisonous or edible, we can use the prediction of a river fill or will it leads to a flood or not. Identifying individual with credit risk, speech recognition and pattern recognitions. So these are the some of the real-time applications of classification. Now in this overall classification approach, we can divide this process into two sub-processes. One is model construction, second one is the model usage. In model construction, we have to construct a model based on the past knowledge. Like in the previous example, we took the student past history or class label like pass or fail and we applied that knowledge on the unlabeled data. Like this, here we have to construct a model describing a set of predetermined classes. That is, describing the predetermined classes. That means how we are going to apply each tuple or a sample is assumed to belong to a predefined class as determined by the class label attribute. Like all, if the student is passed in all the subjects, definitely he will have a class label pass. If he failed in one or two subjects, we will say class label here. Here all marks of a student indicates a tuple. And what is a class label here? Belongs to a predefined class means pass or fail. The set of tuples used for model construction, we will call it as a training data. That means we are taking the help of a training data and the training data knowledge we are applying on the model during the second phase. So here we are taking the data for construction of that model is called training data. The model is represented as classification rules or it can be decision tree or using mathematical formula. What type of classification we are going to use depends on the data set and usage. So the first phase is construction. When it comes to second phase, that is model usage. Whatever knowledge we have taken into consideration and we constructed a model, now that model is going to be applied on the unlabeled data. We are having the marks of the student, but we don't know whether the student is passed or failed. Manually we can do it, but here I am requesting the program to answer. That is, we want to write a program so that it will fill the value. So estimate the accuracy for classifying future or unknown objects. What is the use of it? We can estimate the accuracy of the model. The known label of the test sample is recommended. Here we are taking the test set. Now we'll see what is this test and training set. Look at carefully this diagram here. Here in this, the first diagram, this portion indicates model construction. Look at it. Here we are having the labeled data. If you look at carefully, the last column is the labeled data. Here we are having some name of the person or name of the faculty, experience and tenure. Here we are having data with some class label. This data we are taking as a training data and we are applying the data to the classification algorithm. And after extracting knowledge from this training data, the classification algorithm is ready to apply on any unnamed data. Like here, the model classifier is if rank equal to professor or years is greater than, then tenure equal to yes. That means after analyzing these 6 rows or 6 tuples, The model understood that if rank equal to professor and or years greater than or equal to 6, then the tenure will be yes. That means that is a rule which has been derived from the training data. Now this rule is going to be applied on unknown data. That means usage. The second diagram here, what we are doing? Here we got the data. Let us assume here we don't know the answer. The classifier is going to be applied on unseen data. Look at here. Here we got Jeff, professor 4. Here we didn't find any employee name as Jeff and designation as professor with 4. Then what is the tenure of this new record? Because this record was not encoded during the training. We have given a new record. Now we are not focusing on the name of the employee. What is our rule here? The rank must be a professor or years must be greater than 6. It will look into the rank. Here rank is professor. So based on the rule, the tenure is equal to yes. That means using the training data is used to extract the knowledge by the classification algorithm. The classifier algorithm will derive its own rules and it will try to construct one model. So this upper portion, what we are doing, we are constructing a model here. That is model construction. And in this, what we are doing, we are using this model, that is model usage. What type of classification algorithm? It depends on the programmer and the data and the type of application. So this is upper one is a model construction, second one is model usage. The previous example, like grading of a student. Look at here. X is a student. If student obtains marks greater than or equal to 90, we are giving grade equal to S. That is A. If he is less than 90, there is a possibility greater than or equal to 80 or less than 80. If it is greater than or equal to 80, between less than 90, we are giving B grade. If less than 80, greater than or equal to 70, less than 70. If it is greater than or equal to 70, we are giving C. If it is less than 70, there is two more options. Greater than or equal to 60, we are giving D grade. Less than 50, we are giving F grade. So this is one of the way of classifying the data. And let us letter recognition. Here we are having 5 symbols are there, or 5 components like component 1, 2, 3, 4 and 5. Using these 5 components, we want to form some letters. Like using these vertical and horizontal components, we can construct like using these two, we can draw a letter A, or we can recognize a letter C. We can construct a letter E, can be H or B, letter D, letter F. This is called letter recognition. Now, what a classification technique and how it is going to be applied in any data application. Like the main approach is create a specific model by evaluating training data using domain experts knowledge. Look at carefully here. We are taking the help of training data based on the domain knowledge. Here, the data and the properties of data will differ from application to application. We can't apply retail market example in a share market because both are different. So when we are applying a classification, a domain expert knowledge is mandatory. From that we have to take the training data and we have to apply. So this is used in construction phase, model construction. And after construction of the model, we have to apply the model developed to new data, that is unknown data or unseen data. Classes must be predefined because we don't want to create any new label. Like for student, only 2 class labels, pass or fail. Like for any share market, based on the price value, we can divide the products. So whatever may be the classes must be predefined. The most common techniques are decision tree, neural network approaches. Those techniques we'll see. Just have a look on this diagram here. How the classification is going to be implemented? Let us assume based on the partitioning. In partitioning approach, we are dividing the data. Let us assume if any value which is greater than 5 or between 10, we can say class A. Value between 0 and 5 and in the range of 0 to 4, we can say class B. The remaining portion we can say class C. Like student grades, we can divide into 3. And there is one more approach here. In first case, we divided the data into partitions. But here we are not dividing, we are forming groups. If you look at carefully here, this is group 1 or you can say class A. This is class B and class C. Now what is the difference between here? In partitioning, we can take any one of the parameter to divide the data. But whereas in in distance based, the nearest value is going to be taken into consideration. Like let us say this is center point. There are 5 points are there. Whichever is nearer to this or which will have a similar characteristics, we can form it as a partition. Like this is partitioning of B class B. That is distance based. Now while doing classification, we will have some challenges like issues or technical issues. The first major issue is missing data. If any data is not in a proper condition or if any elements are missing, how can we handle? So this concept already we discussed in data pre-processing approaches. When any data is missing, either if class label is itself is missing, ignore the data. Replace with assumed values. That means by replacing with known values, by replacing with the default values, or by taking the average of the value or mean value, we can replace any one of the missing value. Or we can use some of the measuring thermometers, like some cases we may use accuracy to test the data. We may generate confusion matrix to measure the sensitivity, specificity and accuracy of the data. We can use operational characteristic curves. So these are the issues will come during the classification. If you look at carefully this height example data set, based on the gender, based on the height, we want to give a label. If you look at carefully here, we are having two different types of outputs. We got two different outputs. That means we applied one algorithm on the data set and it was given some class labels like, if you look at carefully, Christina, a male, height is 1.6 meters. The algorithm 1 has given label as short. The second algorithm has given label as medium. Look at carefully. For same person, same gender, same height, two algorithms have given two different labels. One has written as short, another one is written the answer as medium. So if you look at carefully, there are some mismatches. Here, values are matched here, but there is a mismatch here. Here it is matched. There is a mismatch here. It is matched. Mismatch. It means most of the values are mismatched. That means something is wrong in the data. Some of the values are missing or they are not in a proper condition. And a confusion matrix. If we look at carefully using the height data example with output correct and output to actual assignment. So these are the confusion matrix. Now look at carefully here. When we compare actual data with the data which was assigned, we are having three class labels: short, medium and tall. So there are 0 short versus short, but there are 4 values which are recorded wrongly. That is, the actual height of the person is short category, but it was written to label as medium. And if you look at carefully, actual height of the person is medium. It was written to 3 members as tall. Remaining is same. And there is a, based on the actual tall member, for one item it was written as medium. Remaining 2 is correct. That means if you look at carefully, this is a wrong value, wrong predicted value, and this is also a wrong predicted value. That means how we can depict here. So in this, using a confusion matrix, we can compare the actual value and the predicted value. Based on the actual predicted values, we can derive and we can measure the performance. And when you look at the operational characteristics curve, the true positive versus false positive, look at carefully here. Some of the values are fallen below here. Remaining values are which are in, there is a deviation than the original value. This is one of the measurements which are going to be used. Now till now we have seen the basic concepts of classification, that is classification definition, steps which are used in classification like model construction and model usage, and we have seen the characteristics and issues in classification. Now we are moving into actual statistical based classification approach. In this approach, we are going to see one of the commonly used technique that's called regression. So in regression approach, what we are going to do, we are assuming data fits a predefined function, that is already output is known for us. We want to fit exact value for it. Assume data fits a predefined group, determines the best value for regression. Like what we are going to apply here, we are calculating regression coefficients like C0, C1 up to Cn for all the values. Look at here. It is like a basic mathematical equation, y equal to mx plus c, where m is the slope of the value and c is the constant. Like we are repeating this process for more number of points like C0, C1, x1, C2, x2, Cn, xn, and so on, the null value. Here, epsilon. Estimate error using mean squared error, that is MSE. We are using MSE. Look at here. Regression. Now, how the regression is going to be applied? We are going to apply data with a predefined class like class C1, Y with class C2, data Z with class C3. Already the class label is known for us. If we look at carefully here, we are calculating the regression error, that is C0, calculate the coefficients of C0, C1 up to Cn, and we are repeating the process up to I equal to 1 to k. And the error, or the, you can say classification error or regression error, can be calculated by using sigma mean squared error, that is sigma I equal to 1 to k ei square, which is redistributed like this: yi minus c0 c1 x1i whole square. So this is the way of applying a regression algorithm. If we plot the values in linear regression, poor fit. That means if you look at carefully, when the values which are distributed here on a coordinate plane, when we are trying to classify, the values are not properly classified because half of the values which are fallen below the line and some of the values fallen above the line. That means half of the values are not classified properly here. Now, how can we use this classification with the help of a regression? Now, in this regression, we are applying two major functions. They are division and prediction. We are going to apply division and prediction. In division, use regression function to divide the area into regions. We will use regression function to divide the area into regions. Like this is region 1, 2 and 3. Because randomly I took some example. And after the divisioning of the data, we are going to apply another function called prediction. Use regression function to predict a class membership function. Input includes the desired class. That means if any value which belongs to region 1, give a class label as R1. So here we are applying data like this. If we consider that height example, short and medium heights and division here. Look at carefully here. Short and medium, the values here it is 1.6 meters, 1.7 meters. Like this, we are having maximum up to 2.1 meters. If you look at carefully here, the values which are fall below, we are taking as a short, that is between 1.5 to 1.7. Here the y value is equals to 1.7x, that is the average value, or you can say the error value which you are getting, it is 1.786. That means after taking all the values and after calculating the regression coefficient, we got a value that y equal to 1.786. That is at this point we are getting an error while assigning the class label. And we want to predict that value, that is height prediction. Look at carefully here. The height of the person varies from 1.6 meters to 2.4 here maximum. And when we are trying to predict the height, because we don't know the actual value, here we are trying to predict it. When we are trying to predict it, we got two regions, that is region 1 which belongs to shorter, region 2 which belongs to medium range, and we got values 3.63x into 5.816, that is y equal to mx plus c in the format. So if any value which is above this 0.5, we can say it is medium. If it is 0.5 below, we can say so that is class short, or you can say class label called medium. Now using the classification, we can also apply the classification technique based on the distance approach. So in this distance approach, place items in the class to which they are closest to with each other. Like assume we are having some values like this. Here we are having some values like this. Like when we want to form a group here, place items in a class to which they are close. So when let us say I want to form all the items which are close to this point. Like how can we measure? Like I'll take the distance here. Calculate the distance between each and every point, and based on try to form a group here. So that calculation of distance we'll see later. It's not a big issue. We'll use some of the techniques to calculate the data. But here what we are focusing, we must determine the distance between an item and a class. An item and a class. Now how can we calculate? Using some statistical measures like centroid, take the center value, midoid, median, and we are having some of the approaches like you can take centroid, central value, midoid, the representative point, individual points of the data, and we can apply all these things in KNN algorithm. That is K nearest neighbor algorithm. So this is the K nearest neighbor algorithm. So the detailed information about KNN we'll discuss in the next class. Thank you.